Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream. Today we are going to be smashing more of my compiler for my own programming language, for my own virtual machine. We've run into a problem in this journey, and that is that I am unable to do recursive functions properly because something has gone wrong with my stack frames. So let's run my test program and just remind ourselves why this is all the case. I'm just gonna let me pull my console up. Not in that view, this view. Cargo R. And then I just want to xclip. I forgot to put a character in. Excellent. So if I go to my wonderful web-based visualization of this virtual machine, I can compile and run a program, and we see that it, despite this being very small, crashes. Okay, so I did something. Earlier today, I spent a bit of time and I wrote a little visualizer for the current state of the stack. Now, I don't think this quite works properly. And we're going to step through this and we're going to see what happens when I step through. Even with this bad visualization, I think I've realized what happens here. But you can see, in the first kind of frame of the stack, frame, right? So what's actually happening here? What we're seeing is, so our program starts here, right? Say we start at X. This is our kind of, let's call it init. Let's go back to this wonderful GIMP scene. Init has a base pointer of 0. The next thing that happens in our program execution journey is we call main. When we call main, BP is going to be X. Well, no, BP is still going to be 0 because it's the same BP, right? These are the same value. It hasn't changed yet. And PC is apparently going to be 6. So then we create a new frame that says when we called main, when we're in init, when we called main, this is what was happening. So then we keep going. Now we're inside main, right? We've jumped up to main. We do normal function things, and at some point we call another function. Let's call it foo. At that point, the base pointer is going to be, some X, and the program counter is going to be some Y. And this is actually going to correspond, let me use a second color because this is going to get confusing. This kind of corresponds to this function, and this kind of corresponds to this function, right? So, just before, I guess this kind of happens just before we call, technically, but when we kind of make this function call, we have the state of this thing. So from whatever value is in the base pointer, we can find this, and then from this we can walk back and find this, and because this is 0, we know not to go back any further. That might not make any sense, but we can certainly visualize it. Even if it doesn't make any sense, it's a useful tool for me to work out what's going on here. So as I step through this program, you're going to see that things get pushed onto the stack. We've now called a second function. So what this says is, okay, from this base pointer here, so we've got 3 base pointers in play, right? The one that is currently in the register. From that base pointer, we can walk back and find the previous function frame, which has a base pointer of 16372. When we return there, the program counter will be 24, and we think there are things in the stack. And then when we return from that, we get somewhere with a base pointer 0, which means that this was our init function. We don't keep going back any further. This is kind of our guard value. And there are some things on the stack there, but not really. The stack isn't behaving. Also, my visualization of the stack isn't behaving. I think there's 2 problems. One of them is with my visualization. I don't know how much of a problem it is. But we do some stuff. And then we get through this conditional part, and I notice that here, something strange happens. We don't actually jump to the correct spot. We jump to here, and the value that ends up in A is 24. And 24, I can't actually highlight this for some reason, but 24 is the value of the program counter. So essentially we've popped too far back off the stack. We've popped into garbage data on the stack that we should not reach back into. And that makes a lot of sense. That explains a lot of what we're seeing. So we shouldn't be jumping to here. I think we should be jumping to here. And where are we, what triggers this jump? What triggers this jump? Add if PC, PC4. So instead of jumping 1, 2, 3, 4, yeah, instead of jumping 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so we're going 2 instructions too far, I think. Now, actually, I meant to just go here. In PC 102, 102, 110, 102. Actually, hold on, yeah. So not having line numbers is important. Maybe I actually just meant to skip this 1 instruction. I can't remember what this is supposed to do, but here's the thing. The thing I basically noticed is, add if, this offset is actually multiplied by 2 in the instruction. Maybe for the encoding and decoding, I should actually make that explicit. Like if you try and pass an odd number, it cries, and if you pass an even number, it divides it by 2 for its internal representation. Maybe that would make more sense, but for now, we have to wear this overhead manually. So let me change this to 2 and just see what happens if I compile and run this. We still get a stack overflow. One cool thing, even though this visualization doesn't quite work properly, we can see when we overflow the stack. We can see when we blow the stack up. Interestingly, yeah, we end up back at PC 17, which should never happen. We should never have an odd program counter. So what happens here, right? Do I reach that same point? 62, C1, push, push, pop, push. So we're testing to see PC2, push, pop, 110. Oh yeah, that actually went to the right place. I'm pretty sure. 110 is SP. Yeah, this is the return of the function. Add BP0SP. Set the base pointer to the stack point. No, hold on. 110. Set load offset CSP put. See, this whole block here is the function out, and I don't think we did that all. So I think this might be incorrect. 110. Damn, it's so annoying. I really need to be able to visualize which address aligns to which instruction. Colt0 in chat says, hello, I'm currently looking into machine learning stuff because you should increase your understanding of the future of technology. That's a really good idea. One of my old friends from the bank wrote, he wrote a GPT-2 LLM, which was kind of cool. I saw it, he posted about it on LinkedIn. It's like the only interesting thing I've seen on LinkedIn in a very, very long time. And he's just in general a very smart guy. So yeah, it was cool to see. But yeah, so what aspect of ML are you looking at? I would love to do a bit of ML. I would love, one of my long-term projects in my brain is to write a Quake bot at some point, but like a good one. Because people have done, you know, like Frogbot and stuff over the years, but they're not very smart. And I think there's a large collection of Quake replays that are recorded from, you know, top player POVs. There's like huge archives of them from the best tournaments that have ever been played. Surely there's a reasonable data set you could train a bot against. And also, if you just put it up online, you can get people to just come and play it. People still play Quake. And that would be really fun to see, like, you know, to have it running and test it, and also gather more data that you could you know, train it on in some way, hopefully. Maybe I should start crawling public Quake servers and saving all the demos somewhere. Anyway, that's neither here nor there. That's a thought for another day. We're going to step through this again. My favorite button, the step button. Push. So we are into our second layer of function calls. Push, pop, test, add if 1, sp push, pop, test if both 0. Now this is the instruction we've just changed. We end up at PC 92. That is load stack offset here. So I think that's actually correct. I think all I wanted to do was skip 1 instruction here. So we do the right thing. We load C and we pop it into A. That makes sense. then we should jump to the outro, but we don't update the base pointer. $110. Interestingly, this is like the same block twice. So this is... To load stack offset 3. Yeah, it looks like this. Compile body. So yeah, so when we exit the function... Oh no, this is the out. Yeah, so it starts here. It starts here. So it's when we do this, 1, 2, 3, then we have the load stack offset. Okay, so here. So this is where we should jump to, and this is where we end up. So we're 4 bytes off, because each of our instructions are 2 bytes wide. Cold Zero says, you're a bit scattered with it. You watched a video where someone did inference in the mints dataset using Minecraft Redstone. Explained he compressed the mints dataset to 1 bit per pixel instead of 1 byte per pixel. 1 bit per pixel, she said, doesn't impact it that much. Maybe a few % of accuracy loss. What is the the MNIST dataset? Is that the one with the images? I can never remember. It sounds like it's the one with the images. Especially, 1 bit per pixel, sorry. It's interesting, 1 bit per, compressing an image to 1 bit per pixel. Images of handwritten numbers, yes. I have played with that before, actually. I think we had to do something with that in uni. I don't think we did a full recognition training, but I have played with it. It's interesting, right? Because, yeah, when you reduce to 1 bit per pixel, you really are just selecting for shape data. That's, the shape, the form. And that makes sense when you're doing that kind of recognition. If you're looking at pictures of birds, 1 bit per pixel is probably not enough. But a very, a numeral where it's this very binary thing, either it's that numeral or it isn't, it has a very well-defined shape, it makes a lot of sense. And you only view it from one angle. I think that's the other important thing. I did a machine learning hackathon with a friend earlier this year, and there were cash prizes, but we didn't win any because we had to write a trading algorithm for a simulation of a solar battery, and we did not do very well. Okay, so when we jump out of the if statement, something goes wrong. Label out. See, the rest of these references are good. I'm pretty sure this goes somewhere good. Should I dump this into... Look, if I dump this into a new buffer... Oops. It'll tell me what the offsets are, right? So 102, that's going to be 51, which is here. 2, 3, 2, 4, 6, 8. 10, 110, 55. Yeah, interestingly, we seem to end up here, not here, which, again, I don't think is right. Anyway. That's weird, But either way, we expect it to be 109. 109. Oh, not 109, 108, sorry. Well, I guess, I don't need to be too clever here, right? I can literally just change this and see what happens. So what if I go to 108, and I reset, and I run? We still blow up the stack. Why? What happens? 0, push. Because I didn't compile it? Where did 110... You saw that, right? It still said 110 in here. Let's go through LTE, push, pop, both 0, PC 108. Here we go. Okay, so we're still not quite doing, so it's 106 is what we want. Reset, compile, run. And we get an answer. Okay. So this offset is wrong by 4 for some reason. And this is good. It's good being able to just play with the assembly like that. And this is why it's useful compiling the language and then immediately disassembling it and working from this disassembly to actually do anything useful. I think that's a cool way to work. Cold Zero is looking at something you've seen in the past. ML thing for converting signed distance fields into shader toy ray marching compatible matrix vector calculations. Can take a 3D model, convert it to a signed distance field, then train a model on that signed distance field and output a series of maths that can be plopped into ray marching. That's really interesting. Because yeah, I guess SDFs are actually quite good for that, right? You're just like, you know, I guess neural network or whatever. And it can just, it's kind of like dumb iteration, but you have that weight that helps you hone in on a better solution. That makes sense. That's cool. That's really cool. That's really cool. Okay, so why is this wrong? This is hard because this label resolution is a little bit quiet. It's a little bit hard to get my hands on the inside of. Why would a label offset be so wrong? Why would it be so wrong? Label. Because it was wrong before as well. Okay, well, here's the other thing. Here's the other thing that's kind of interesting, right? What if I just hit the other branch? So what if I make this 1? What if I make this 1? If I reset and I compile and I run, we still come through. Okay, so this other branch, 102, because that jumps, hold on, 102. So that must go here, 1, 2, 3. Yeah, so that's right, 6, 4, 2. Wait, that isn't right. Because if this is 106, then this is 104, and this is 102, and this is 100, and this is 98. So if I it's like a fluke that this works. If I step through this again, right, we'll see that when we get to here, so, okay, so this is 106, 4, 2, 0, 98, 96, 94, 92, so this should be PC 90. 2, 4, 6, 8, 90. Okay, no, so this is 92. 102. But it does skip over this, so I just can't count. So this is wrong. This is out by 2 and this is out by 4. And this gives me a very bad feeling deep in my soul, because this feels like a very subtle bug that I've introduced somewhere. Now I have to unpick. So why are my labels wrong? Why are my labels wrong? Okay, here's a thought. It would be cool if we could print out the program as we see it before we resolve all these labels. That would be meaningful and interesting. So what if actually, wait, hold on. Oh wait, this doesn't work. This really doesn't work. Because this counts all labels as instructions, which explains why it gets more and more out the more labels we define. Okay, so what I actually need to do, forget this, so we need to let mut offset. So we need to count the size of each instruction. And everything that isn't a label has a size of 2. Where was that? This file is getting quite large. Otherwise, offset plus equals 2. Define H. Where did H come from? Did I just do that? Did I do a funny vim find and replace by accident? Found symbol. Maybe define should take a ref to a symbol. It does take a ref to a symbol. Wait. Expected, oh. Actually, it wants this. This is the better solution. The borrow should be there. Okay, so now, if I build this, and if I paste this in, what do these offsets look like? What do these offsets look like? B0, C0. Wait. C0. I think that was a stupid copy paste, as happens sometimes. Okay, now this looks correct. So if I compile and run this, it runs happily. And if I change this arg so that it hits the other branch, and I compile and run this, it also runs happily, and we get the expected values in the A register. Okay, so here's what we're going to do now. We're going to go back to test.code. We're going to undo the part. We're going to do shitty Fibonacci numbers. We're going to see how these go. We're going to paste in here. This looks so weird. Why has this not compiled? Why don't I have the whole thing? Why do I have to do this twice sometimes? Like, where's... Okay, well, let's just see what happens if I compile and run this. Yeah, something goes wrong. And of course it goes wrong, because it doesn't look like I've got the whole code. Oh no, here it is. Wait, why are these in a different order? What the hell? That's really odd. PC16. Why is this all jumbled up? What have I done? This is really strange because we jump, but this is where we, have I got a race condition somehow? This is like the end of, or can they just go out of order? That's so bizarre. There we go. This is the right order. This looks better. PC62, PC, I think. Yeah, there we go. Okay, so that was weird. That was very weird. But we can run this and it appears to... Did I quit that for some reason? Okay, so what if I continue to undo? This is the real test. This is the moment of truth. Can we calculate the ith Fibonacci number using our code? And for some reason, yeah, the order of this... are we relying on iteration order of a map? Huh. I hadn't thought of this. Iteration order of a hash map isn't guaranteed. Maybe this is the problem. Okay, we're still just getting the argument. We're still just getting the number 5 back. That's not... The 5th Fibonacci number is not 5. The good news is we don't crash. The very good news is we don't crash. So what if I step through this? What happens? Okay, excellent, excellent. I don't know why... Oh, actually, I do know why these stack frames look so funny. But I don't know why there's so many 5s here. There shouldn't be so many 5s. That's a little bit wrong. So we push something to the stack. We push something else to the stack. I don't know, again... There's something a little bit stanky going on with how this stack grows and shrinks. Okay, we push C to the stack. We pop A. We jump to 144. Let's see. Now, okay, so that shouldn't happen. We didn't do recursion. We didn't do enough function calls at all. I think I need better tests, right? I think I need a more automatic way of testing this rather than me just going crazy slowly. I am such a goat. Hello, welcome. Welcome to this descent into rust and madness. I'm just going to catch up on this chat message. You applied something you found through a YouTube video recently. Grok fast, grok into training, gradient, reduce loss. Yeah, cool. I can't really quantify this, but that does sound good. 20,000 steps, reaches, yeah, so that's like, you know, what, 40% less steps or something, 30% less steps. That's cool. That's really cool. Yeah, ML stuff's cool, and you know, that might be a fun project. You know, might be good for the algorithm. That would be cool. Okay, so we're gonna also grab the how do I... Is it namespace like this? I actually don't know. Or is it just this? Lang. Can I import from a binary package? Maybe I have to I don't know, just because this is just a test. Yeah, yes. Yes, I can reference it. Zaka. Is it, was I right? Should I just try it? Simple VM lang star. Also, it's not teased. Compiled. Okay, so let's also go into, well, okay, if it's in the same workspace, I'm good. That sounds good. Okay, so we're gonna try functions that return things in sequence but don't take arguments, because that should be simpler. So return B, and then function B will return C, and function C will return D, and function D will only then return 7 plus 8. Okay, I think this is good. I think I'm onto something good here. Same workspace, I'm good. Awesome. 8 months into your compiler, still no tests. This is very scary. This terrifies me. Zaka, thank you for the follow, by the way. I think you followed me before I went live, right? But only it was like 3 minutes before I went live or something, which is kind of cool. Just like good timing. Good timing. Weird timing. especially with how irregularly I stream. Okay, but welcome anyway. What is your compiler? Is it like a C-like language? Are you doing a Lisp? Are you doing like what's happening? Awesome, yeah. Click compiler stream when I logged off. So I need to pass this. What do I have? Run parser. This one. Ooh, C-like, unsafe. Are you writing it in Rust as well? And the loaded program offset's going to be 0 because this is going to be a simple machine. Excellent. Instructions. And we're just going to unwrap everything because it's a test, and that's fine. And then these instructions, we're going to do this encoding as well, I guess. Maybe I need a helper function for loading a slice of instructions into my VM. That might be cool, so I don't have to copy this everywhere. Nice. How are you finding Rust for a compiler? Because, like, you know, the type checking and stuff, like, it kind of makes it safer to not write tests in a sense, because the compiler yells at you when you break stuff. But, yeah, it's nice. It's nice. I don't know. I'm having fun. I'm having a lot of fun. Okay. Always correct. Not always, but more than other languages. You know, we're not writing Idris here. We're not writing, what's that other one called? Idris is like the golden child, right? Everything is magically handled by the type system. Okay, so we've got our set of instructions. We need to make a VM. Except I have a helper for this. Run program code. Oh, I have a helper for running a slice of instructions. Excellent. That's really funny. Do I have a standard machine? Yes. And then we just say run. Excellent. We don't actually need this anymore. And then we just assert the A register should be 15. Except that was the wrong bracketing. God, you can tell I've had a big day today, can't you? Okay, so what happens when I make T? Could not find lang. What if I just do lang? Maybe I can't do this. It doesn't really make sense. Maybe I should, maybe this is just in the wrong place. Maybe this needs to be in... Actually, but that doesn't work either, does it? Maybe not. In C++, you remove an enum variant, you're paranoid. Yeah, there's more quiet errors, I guess. Especially the handling of enums and like having a good match statement. It makes a really big difference. Hardest compromise feature is generics. You think C++ generics, there's something you miss from them that you can't get here? Because I know there's like a little bit of specialization you can do in C++ that you can't do in Rust, but I don't know how much I miss it. Oh, in your own language. Yeah, holy shit. Writing generics, man, that's like a different level. So what if I go into... This isn't running this. Thing. I also can't search that. Okay, so that didn't do anything. Rust. This I think might actually be what I want. Name equals this? So what I probably actually want is a more sensible project structure where I have... Where did this file come from? Where did this folder come from? What the hell? That's weird. That's... I don't know how that... I don't know what happened there. What I probably want is a whole folder in here, like a top level folder called lang or something, or maybe source lang. Maybe I just make it part of the source crate. Maybe, I don't know. There's a lot of different ideas in my brain right now, but for now I'm gonna do something stupider because I can't mentally deal with that refactor right now. So what if, I mean there's nothing stopping me, right? Just for now, don't hate me. Actually, wait, no, that's fine. Yeah. This is what I don't currently have, and this one repo has outgrown the structure that I have. But I don't want to tackle it all right now, so I'm going to do something dumb. I'm going to do something stupid. It's going to be fine. It's not in source, it's in tests. Okay, and then I'm going to do this. Oh my gosh. Okay. I might rename this to mod. Wait, that was the wrong thing. That was the wrong one. Oh my gosh, my brain today. This gets the job done. Core library, CLI, LS server. Oh, you've got a language server as well. That's kind of cool. I don't even use a language server for Rust, so I'm probably not going to write a language server for my language. Core library, CLI, yeah. Because this repo, like technically this is just the virtual machine repo, so maybe putting the language in here as well is unnecessary, but also I don't think it's worth putting it in a separate repo because it depends so heavily on this, and I'd rather not have to, depend on an external library. Like, they can just live in the same repo, it's fine. Yeah, mono is good, especially in this case. They're going to evolve in step with each other. Okay, so now now I need, use crate. Perfect, now we're done. Maybe? Actually, register we can keep, that's cool. Code stir, so we want test. What else do we have? Use simple VM. Wow. Apparently we don't use that. Get instructions. This needs to unwrap. Expected machine. Yep, that makes sense. We need to mutably borrow this machine. What else do we have? Get register. Everything for enum. This also needs to unwrap. Excellent. Well, that's better. That is better. But then we can unwrap this too. Everything unwraps. Everything unwraps. Okay, now we've got a problem. Shandu16, hi, welcome. It's going well, it's going well. Zaka says the only external thing LS client that's in TypeScript. You'll never mix TypeScript with the real code. TypeScript's real code. Come on. TypeScript is solid. I'm an unironic JavaScript appreciator. It's not my favorite thing to write, but for small hacky scripts, you can really do some fun stuff with it. Like if it's less than 200 lines, I've got plenty of web pages I've hacked on over the years where I have a script tag just in the page, all my JavaScript, 200 lines or less in the page. Even, if I go to my my visualizer, right? Like this is just a couple of 200 lines of JavaScript. And it's all just doing really simple stuff like setting inner text and updating a canvas. It's kind of good. It's kind of nice that it can be simple. Are you reading or following any tutorial for booting a compiler? No, I'm doing this mostly from the top of my head. It's a really dumb compiler, but it's a start. And then I'm going to go and read some things. For example, I have in my 8-register machine an entire register devoted to the base pointer for my stack frames, and I think that's kind of dumb. And I know that there are alternatives to using a base pointer. The only way I understand stack frames is through a base pointer, but I'm going to go and do some reading once I get it working and change my calling convention. But there are really good tutorials out there. If you want to learn about languages, not so much from the compiler side, but the book Crafting Interpreters by Robert Nystorm is really cool. I've got a copy of that and I've read that. I haven't implemented most of it, but I have read it. So that's quality. I recommend it. That taught me a lot of stuff. And then as far as the inner workings of the compiler, I'm really making it up, which is fun, which is very, very fun. Okay, so that blew up. What blew up? Unknown signal effort. Oh, I forgot that I have to define things differently for this machine. This machine expects things different. What is sigholt? 01, apparently. Okay. I'm just going to change this to FO. I think that's the easiest thing to do right now. Excellent. And that passes? That's weird. I didn't think that would pass. Okay. That makes me happy. Now let's do a more complicated version of this test. Let's call this deep calls. Let's call this deep arg calls. And now we're going to pass 2 arguments in with every layer of this function. X plus 1, y plus 2, int x, int y, x plus 2y plus 3 in x in y, x plus 3 x y plus 4, and then d takes int x in y, and we get x plus y. Now I need to just calculate this real quick. Also, yeah, sorry, VS Code configs are hugely annoying. I agree, that's why I use a very minimal nvim setup. Like I said, not even using LSP. I don't get a red squiggly line when I make a typo. I have to wait until I build and then use my quick fix list to resolve that. Okay, so 1, 2, 4, 7 plus 4, 7, 11, 15. Is that, wait, did I fluke that to the same number? That can't be right. Let's find out. Deep arg calls and deep arg calls failed. That's interesting. Deep calls failed. Oh yeah, is this yeah, deep arg calls failed. 12, 15. That might just be because I can't do maths properly. And arg calls failed. Deep calls failed. 0 instruction. Yeah, I think these functions get realized out of order. Okay, so if I go to compiler, if I go to, where do I actually put this together? For each top level statement, that's okay. We compile the body. That's also okay. Then we update the program offset. So it should be the order they're defined in. So why do we sometimes seem to get these out of order? How can that happen? How can that happen? It's not like we're putting this into some kind of map. Like all of our hash maps, we loop over locals, we loop over args, init, functions, instructions. See, so functions is a hash map. Okay, so maybe this is where it happens. Get instructions. Oh yeah, because this is where we actually get the instructions of, yes, the order this comes out is non-deterministic, right? Because Rust hash map iteration order arbitrary order. That's the keyword. Arbitrary. Let's keep going. Arbitrary. Arbitrary. Okay. So, is there a type that lets us just do this? B-tree map? I don't want to sort them. That's also not correct. Unless I guess dot sorted. Unless I can sorting values sorted by key, sorted by value. No, sorted by key, sorted by value. X dot hashrap string sorted by. So how does sorted by key work? What's this? Where does that come from? What the hell? Sorted by. Let's go into the docs. Sorted by. Sort by key. Where did this come from? Itertools. I don't know if I want to pull in a dependency for it. B-tree map if I need sorted. Maybe I should just use a B-tree. B-trees are cool. I also just like B-trees as a data structure. B-tree map. Yeah, okay. I'll just turn it into a B-tree map. This is the only place it should matter. And is this just going to be the same API? Oops. Actually, wait, is it sorted or is it sorted like ordered map? Sorted by key, but sorted. I need insertion order. I probably can. Actually, hold on. Yeah, the only time I iterate over this, I ignore the key. So yeah, you're that's very funny. That's like the worst thing I've ever done. Yeah, I mean, it depends. Maps are under 100 items. It depends. It depends on what you're building for, right? Like, looking things up in a vec is very fast. This is very true. But also, sometimes you want the API to have a certain shape. Like, performance isn't the ultimate goal all the time. Sometimes, yeah, I'm more concerned with the shape of the API than like getting speed. And nothing about this compiler is fast or performant. There's a lot of places that I can pull out performance before I'm worried about that. So now this is a push, and we just forget the name. And does this build? It does. Does this test? It does. Okay, well this gives us the right answer, which is good. Now we don't have to have that horrible just compile a couple of times and hope they get defined in the right order thing. Left 18, 15. Now, it does strike me that there's a chance that I just added this up incorrectly because I didn't make my life easy here. So it's 1 plus 1 plus 2 plus 3. 1, so 2, 4 plus 3 is 7. 7 plus 2, 9, 11... 14, 18. It is 18. I just can't do maths. Oops. Okay, and that works as well. So now we need the third and final test, and this is like the big one. This is the one. This is the big boy test. Okay. The one where we do recursion. So, what does our recursive function do? I mean, Fibonacci number is a classic. Let's say if A is less than or equal to 1, then we're gonna return B. Actually, that's not very interesting, is it? This isn't the most interesting thing I've ever done. But this has some merit because it's got a very simple and predictable return value, and it should just get called a couple of times. And it also has 2 arguments. The point of, having 2 arguments rather than just a-1 here is that this argument, like, it'll be more obvious if the stack gets corrupted. Because if the stack gets corrupted, it should blow up, I think. Maybe not. Maybe I could make something where these 2 things are more interdependent. Let's find out what happens when I run it. Beautiful. Parse error. Expected token. Okay, well that's not what I expected. If A is less than or equal to 1, return B plus 1, else return A. Oh, I've overloaded a variable. That's got to be very confusing for the compiler. I don't think that's why it didn't parse, but let's find out. At what point was it easier to just rename the function than the variables? Okay, yeah. So this whole function fails to parse for some reason. That is annoying. Control flow is where all the fun lies. Yeah, I've got a lot of thoughts about got a lot of thoughts. I mean, my if statements are pretty close to working, which is good, but just some things not quite happening. Oh, this is A. What am I doing? My brain is a little bit fried today. What is going on? Well, this has to be a return. Sorry, that makes sense. This also helps. Return Y, return. Why doesn't this parse? What have I done wrong? A in X in Y. Is it because I have no? But two args is okay there. Return. Weird. Let's just keep pausing this. Let's keep pairing this back and see if we can work out what's gone wrong. It's really hard to read my compiler errors when I'm in a test, which is maybe a problem. If X is less than Y, why is this not working? What the hell? Okay, I guess I just have to read this. So context here, parse error, context, expected a. Oh, my if statements have to be right. Okay, hold on. Let me undo a bunch of stuff real quick. I need a semicolon at the end. My compiler error did actually tell me that. Then I return I, and I want to do that up here too. You've got a defer keyword. Defer is a really cool keyword. I rate defer. I rate defer. Okay, left. So this is good. This is good. We're getting somewhere. 15.1. Return. Okay, now we can see that things aren't working properly. Now we can see. Value in the A register isn't correct. And what if I do this as well, right? What do we get here? We'd get 15 minus. So 15, 1, 14, 2, 13, 3. Yeah, okay, let's do this. So it's not returning anything correctly at all. So, okay. We have proved that recursion is broken. We've fixed the branches of if, which is good. So maybe this program is a good candidate to step through in my machine. Cool, yeah, so we get we just get nothing, which is not great. So 0b, we jump to another place in the program counter. So what are we doing? Stack, push, load offset, 3, push, pop. We do our comparison. We set up 0 for the test, which is very, very silly. I really abuse the stack. It's very, very wasteful. We step over an instruction, then we have this PC 104. Okay, so we jump to 104. 104 must be this, where we jump back. What is this? See, SP push, load, push. We subtract 1, and then we store this. Do we? No, we get C push, SP add, then we jump back. And then we go in again. We do this test. So at least it's doing things multiple times, which is good. 0C, load C0, push, pop, load offset. So we get the number 6. I don't know where the number 6 comes from. Now we've ended up at the end. Okay, I have no idea what happened there. Also, we accidentally wrote some garbage to the screen, which is funny. I think my stack might actually be overriding the screen. Where does this even happen? Yeah, it must be the stack. I feel like I've made very little progress today, apart from fixing my if branching, but I think I'm gonna have to leave it there because it's getting a little bit late. I've got to be up. Well, I might get up and stream early tomorrow. That might be my concession. Add an else if. Yeah, well, I'm probably gonna add an elif just because it's easier to parse. But yeah, else if would be useful as well. There is also the option of just parsing an entire statement after an else, and then you could have another if, and it's not as efficient, but you know, that would at least get me started for now. The point of this language isn't to be good, it's to just let me write code for this machine, and then maybe I can use that language to write a compiler that runs natively on the machine and can compile itself. That, you know, that's kind of where I'm going with this, maybe. The more I can escape normal computing, that would be cool. Anakim Luke, hello, good morning. Well, good evening, I should say. It's 11:15 p.m. and I'm probably going to kick you guys onto someone else cool. So if you guys have any recommendations for someone to raid, give them a shout. Give them a shout now. No engine C style random game dev. That's pretty good. That's a pretty good sounding stream. What have we got? Junior Programando. New and Learning, Next.js, LeetCode. Making an AI learn to play Celeste. That sounds kind of fun. Let's throw some viewers over here. Let's do some AI. Let's do some AI. We'll raid this person, and then I'll hopefully be back in probably less than 12 hours, depending on how I sleep. And I'll do a morning stream because, oh boy, tomorrow's gonna be busy. I'm playing Irish music in the afternoon. All right. Thank you very much for coming and tuning in. I'm Tom. I will catch you all next time, hopefully very, very soon.